So if you have your book, how many? I don't see many books. Okay, there we go. Okay.
I own the book, but I didn't read it.
Okay. Okay. In the book, page 1, there's a picture of like a coffee cup. You know, when we start out, and all of the little writings on it are like this. Anybody know what this is? This is a what? A slide. A slide rule. This was the technology that was used in lieu of a calculator when we put a man on the moon. Okay, so there's more technology and power in your iPhone than all the computers that put the man on the moon. But anyway, it works something like this. You would try to figure out how to multiply numbers, and you would have to line this up and read your answer. So anyway, this is using logarithms. This was like the calculator of the 60s and 70s. We will not be going into that, but that's just sort of where that comes from, and we'll be talking about logarithms today. Yes, sir, Jack.
Neil Armstrong was the first man on the moon.
He was.
Neil A. backwards.
Okay. Everyone write that down. That will not be on the test. So we'll be good there. We have quizzes. I use the word interchangeably, so we're good. So what we need to talk about today, I need you to recall some things from last semester, and we're going to join them with some things from this semester. So the last thing we covered was exponentials. Okay, that was on your final. That was the last unit that we did. We're going to talk about logarithms today. Logarithms are the inverse functions of exponentials. We did talk about inverse functions last semester as well. So I've got two functions graph here, 2 to the x and the log base 2 of x. 2 to the x, how did we graph 2 to the x? We picked how many points? How about 3 points? We picked 0, and we picked the numbers on either side of that. What's 2 to the 0? 1. What's 2 to the 1? 2. What's 2 to the negative 1? Okay, let's pretend like we had a final, and this would have been on it last week. 2 to the negative 1. 2 to the negative 1 is 1/2, okay? Okay, so that tells me if I'm graphing 2 to the x, all 3 of these points should be on that graph. So, negative 1, 1/2. That looks like this point right here. 0, 1. That looks like this point right here. 1, 2. That looks like this point right here. This is the graph of 2 to the x. Okay. Now, the inverse function is called a logarithm function, so the log base 2 of x. But when we learn inverses, the inverse function basically switches what? The inverse of a function switches the roles of x and y. Okay. So, if this point is on the graph, what point is on its inverse? 1/2 negative 1. So if I look at the inverse of 2 to the x, it's going to have the point 1/2 negative 1. What other points will be on that graph?
1.
1, 0. And what else? Okay, if I'm going to draw the inverse of 2 to the x, those points have to be on the graph. So let's look at that. 1/2 negative 1 looks to be this point right here. 1, 0 looks to be this point right here. And 2, 1 looks to be this point right here. So when I draw the curve there, this is the inverse function. Okay? So here is a function 2 to the x. Here is its inverse. We call that function the log base 2 of x. You know conceptually, to square something, what's the inverse of squaring? Square root, okay? The inverse of cubing is to do what?
Take
Cube root. The inverse of adding 3 is what? Subtracting 3. So those things you know conceptually. This is a hard concept because you don't know what a logarithm is, okay? But we've defined this function. We'll talk about it in a few minutes, but this is the inverse of an exponential. That's all the logarithm really is. Now, domain and range. Again, this was on the final. I'm hoping that you've got the skill of looking at it. 2 to the x, that's the red graph you see here. The domain is the set of all what?
X values.
Okay, so how do I find the x value? What are the x values on the red graph? They go from where to where? Yeah, from negative infinity to positive infinity. The range is the set of all what? Y values. It's the only time I ever look at the y-axis for an interval. So looking at the red graph, are there any y values down here? I don't get y values until I get to where? 0, and I keep having them until I get to infinity. So that's the domain and range of 2 to the x. Now, if log base 2 is the inverse, what's the relationship between domain and ranges of functions and their inverses? The domain, if x and y change values, if they change roles, yeah, the domain of this one is the range of its inverse, right? So it tells me that the range of the log should be negative infinity, infinity. So let's look at this graph. What's the range? The range is the y values, negative infinity to infinity. So the range is negative infinity to infinity. What do you think the domain is for the log function? Yeah. The domain of this blue function you see here is 0 to infinity. Okay. So those are just properties of inverses. Okay. So the logarithm function is it's just the inverse of the exponential function. So we're not going to be doing a lot of graphing of logs, but we'll be doing just some more manipulation of the function. Now here's a definition. You don't really have to memorize it. It's really going to come to you more in practice. But if the log base b of y is equal to x, that only works if b to the x is equal to y. Now here's, I know it may be confusing, but let's just look at it this way. You're familiar with this right here, b to the x equal y, okay? Which of those things is my exponent? X, okay? Which of those things is my base, the thing that's raised to an exponent? B. So the base is b, the exponent is x, okay? When I write it in log form, where do you see the base? Right there, log base b. Where is my exponent in this equation? Where did it go? Other side of the equal sign, all by itself. Okay, that's all you really need to know, is these are two different ways of writing the same thing. X and y changed roles. So let's look at this. This is an exponential. What's the base? The base is 3. What's the exponent? Now I'm going to write that in log form. Okay, so the log base b. So I'm going to say the log. What's the base? 3. So the log base 3. In exponential form, my exponent will always be on the other side of the equal sign, all by itself. What's the exponent? 2. So on the other side of the equal sign, all by itself, I'm going to write a 2. What's the only number I haven't written yet? 9. There we go. The log base 3 of 9 is equal to 2. Okay. So these are equivalent expressions. This is exponential. This is logarithm. Okay. So when you look at a log equation, this subscript, that's your base. Your exponent will always be on the other side of the equal sign all by itself. This means that 3 squared equals 9. Okay. So it's a way of solving for the exponent. Let's look at this one. What is the base? 2. What is the exponent? Okay. I'm going to write that as a logarithm. So I'm going to write log base what? Log base 2. Where will I write my exponent? Other side of the equal sign, all by itself goes what? X plus 1. What's the only number I haven't written? 7. Okay. Log base 2 of 7 is x plus 1. This means that 2 to the x plus 1 equals 7. What is the base here? The base is 10. What's the exponent? We have 2x. So when I go to write that in log form, this is log, and then my subscript, what is my base? 10. And then where do I write the exponent? Other side of the equal sign, all by itself goes what? 2x. What's the only number I haven't written yet? 121. Okay. Log base 10 of 121 is 2x, because 10 to the 2x, that's my exponent, equal 121. Okay? So remember, in log form, this is your exponent. Your exponent is always on the other side of the equal sign all by itself. Now don't get confused. Like, you know the exponent here is what? It's 2. So don't get confused. Last year some people were like, oh, exponent is 9. No, you knew better than that. Okay, you knew the exponent was 2. In exponential form, you know where the exponent is. It's the superscript. That's the exponent. When you write it in log form, that's a way of solving for the exponent. So the exponent is always on the other side of the equal sign all by itself. Now, let's take things that are in log form and write them in exponential form. Okay? So in this case, what is the base? The base is 7. And then which of those numbers is the exponent? The exponent is 2. In log form, the exponent is always found by itself on the other side of the equal sign. Now, to write this in exponential form, this means 7 to what power? 7 squared equals 49. That's exponential form. Okay? What's the base here? 4. Which of those numbers is the exponent? 3. 4 cubed is equal to 64. Okay? What's the base here? Now, e is a number we'll talk about in just a few minutes, but the base is e. So what's the base here? E. This means e to, what's the exponent? E to the 0 equal 1. Remember, any number to the 0 is what? 1. Okay? What's the base here? 2. What's the exponent? Yeah, 2 to the negative 3 is equal to 1/8. Remember, 2 to the negative 3 is the same as 1 over what? 1 over 2 cubed, which is 1/8. Okay? Yeah, it is. I'm not sure what's going on there. Now, a couple other things about logarithms. There's something called the common logarithm. All that means is the base is 10. Okay? So anytime you see a log with no base, the base is assumed to be 10. Okay? So the log of 25 means log base 10 of 25. So anytime you don't see a base, the base is 10. That's called the common logarithm. Okay? So in this case, log 10 of 100 equal 2. What's the base? What's the exponent? 10 squared equal 100. Okay? That's where that comes from. Now there's another base called e. It's like pi. It's called Euler's number. So it's a number like 3.14159, but it's 2.71828. It is a number. We're not going to go into how it's derived, but you'll see this base commonly referred. Yes, why? Question?
You say that was your favorite?
My favorite is the equation, Euler's equation, which is what? E to the I pi
But you guys didn't know about that.
equal -1. So we can't go into that. But I mean, because this is a complex number, that's an irrational number, and that's an integer. Yes, question? Sure. Okay. Okay, that's not going to be on your test. That's a little bit beyond. Perhaps, if you can prove it. So, okay. So, anytime you see log base e, another way of writing, that's called the natural logarithm. Another way we write that is ln of y. Okay, so anytime you see something like ln of 20, all that means is log base e of 20. Okay, so ln means natural log, or the base is the number e. Okay, so let's look at a few examples of this. I'm in exponential form. What is my base here? Yeah, the base is e. What's the exponent? No.
2.
Exponent is 2. You know better than that. The exponent's on the other side of the equal sign when I see what? A logarithm, okay? Okay. Here, the exponent it's a 2. You know what the exponent looks like there, okay? So to write this in logarithm form, this means the log base e. And where's the exponent going to go in this log equation? Other side of the equal sign, I'm going to write what? A 2. Okay? What's the only thing I haven't written? The y. Okay? So the log base e of y is equal to 2. This means that e squared equal y. That's the definition. Now another way you might see this is just you might see ln of y equal 2. Those are equivalent expressions. When you see ln, that's natural log. That means log base e. Okay? You can write either of these. Doesn't matter. You have to write one or the other of these. These are the two ways. So it doesn't matter to me which you write, but you just need to be comfortable. When you see something like this, what does ln mean? ln means log base e. Okay? Now let's convert this to logarithm. What's the base? Yeah, the base is e. What's the exponent? Exponent is 1. Now to write this in log form, I'm going to have the natural log of, so that's log base e. Where does the exponent go? Yeah, it's going to be this. And what's the thing that I have it written is what? 2.71828. So another way of writing this is log base e of 2.71828 equal 1. So we're going back and forth between exponential form and log form. This one you know, exponent is 2, exponent is 1, exponent is negative 2, exponent is 0. When you write it in log form, your exponent is always on the other side of the equal sign all by itself. And this subscript, this is your base. E to the 1 equal 2.71828. Okay, look at this one. The base is what? The base is e. What's the exponent? Exponent is negative 2. When I write this in log form, I'm going to get the log base e. Where will my exponent go? Other side of the equal sign all by itself. And then what's the only number I haven't represented here? Y. So the log base e of y is equal to negative 2. What's another way of writing that? ln of y is negative 2. These are the equivalent expressions. Log base e and ln. Those are natural logarithms. Log base e. Okay, this one. What's the base? E. What's the exponent? Exponent 0. So I'm going to have the log base e. Where would that 0 go? Yeah, other side. What's the only other thing I haven't represented? 1. Okay, this means that e to the 0 equal 1. That's what you see there. E to the 0 equal 1. Okay, so you need to be comfortable converting between exponents and logs and exponents. Okay, in exponential forms, you know where to find the exponent. It's where you've always seen it since middle school. In logarithm form, the exponent is always on the other side of the equal sign all by itself. Okay. Now, having graded your final exams, I'm not sure you know this or not, but we'll see if we can remember this. Inverse functions.
Oh yeah, do not know.
We get honesty from the front row here. So, okay, think about it. Okay, if there's a function called driving you to school, okay, you left your house this morning, you got to school. The inverse function is going to do what? Yeah, inverse function this afternoon is going to take you from school back to home. Okay, that's what the inverse function will undo whatever you did. Okay, so if I square something, that means a 3 becomes a what? If I square something, a 3 becomes a 9. To undo that, I'm going to have to go from a 9 to a 3. What takes me from a 9 to a 3? Square root. Okay, that's what inverse functions do. A function will take you somewhere. The inverse function will do what? It will bring you back. Okay, so if I start with x, if f and g are inverses of each other, f will take me somewhere, but g will do what? It will bring me back to x. Okay, and if I start with g, it takes me somewhere, and f will do what? It will bring you back to where you started, okay? So f composition g or g composition f have to equal x. You start with x, you do both of these functions, you're going to end up where you started, okay? Now, the log function and the exponent functions are what functions to each other? Their relationship is, they're what? They're inverses. So if you apply an exponential and then you apply the log, where will you end up? These are inverse functions. What will it do? The exponential will take you somewhere. What will the log do? Take you right back where you started, okay? What about the log function? The log function will take you somewhere, but the exponential will do what? Take you back where you started. So all this means is the log base b of b to the x is equal to, I mean, look at it. Log base b of b to the x. What is the relationship between the log and the exponent? These are what functions? The relationship to them. They are what kind of functions to each other? Inverses. So that means wherever you start, you're going to end up. So if I have the log base b of b to the x, I'm going to end up with x. I end up where I started, okay? You start with an x. If you have an exponential, that's going to take you somewhere, but the log is going to bring you right back, okay? Guys struggled with this last year, but I'm going to try to write this in G-rated terms. Log base b to whatever the heck. I don't care what is up here. It doesn't matter. It is, that's it, okay? Log base b of b to anything is that anything, okay? These are inverse functions. So if I have b and I raise it to some power, but I take the logarithm, I get what I started with, okay? So same thing here, b to the log b of x. These are inverse functions. So if I had b, raise it to the log base b of whatever the heck, what's the answer going to be? Whatever the heck, okay? So, yeah, these are just inverse functions. It's like saying if you square 3 and then you take the square root of 3, what do you get? You get 3, okay? If I add 3, if I take any number and I add 3 and subtract 3, what do I get? The number you started with, okay? That's all this means. If I take an exponential of any number and then take its logarithm, I get the number I started with, okay? So don't waste time trying to say like, oh, this is complicated, whatever it is. Log base b of b to, I don't care what it is, that's the answer, whatever that exponent is, okay? So now let's solve a few things without a calculator. The log of 1,000, okay? What's the base here? 10, because it's not written. So I don't know what this is. I'm just going to say it's x, and I want to solve for x, okay? What this means is the log base what? Place 10 of 1,000 equal x, okay? The way to solve a log equation is to convert it to a what kind of equation? Exponential, okay? What is the base here? 10. If I look at that equation, which of those things is my exponent? X. Okay? Remember, in a log equation, the exponent is always on the other side of the equal sign all by itself. 10 to the x equal 1,000. What's x equal to? Nope. What's 10 squared? 100. What's 10 cubed? 1,000. So x is equal to, this was the kind of an equation you would have solved last semester. Okay, 10 to the x equal 1,000. X has to be equal to 3 because 10 times 10 times 10 equal 1,000. Okay, what is ln? Ln means the what? Log base e. It's natural log. Okay, so I don't know what this is. I'm going to say it's equal to x, and I'm going to try to solve for that. So ln of 1, this means the log base what? Base e of 1 is equal to x. That's a logarithm equation. I would rather solve it as a what kind of equation? Exponential. Where's my base? E. In this equation, which of those things is my exponent? X. e to the x equal 1. What must I raise something to get a 1? 0 power. X is equal to 0 in this case. So you need to be very comfortable with exponential form, logarithm form, going back and forth between the two of them. Now, anybody know what this one is? Log base 12 of 12 to the 7th. What's the relationship between an exponential and a log? They are what? Inverses of each other. So log base 12 and 12 to a power, what are those things? They're opposites. They're inverses of each other. What do you think my answer is going to be? Huh? 7. Answer is 7. You take 12 to the 7th. That means you've done an exponential with a base of 12. 12 to the 7th. What would undo 12 to the 7th? What function undoes an exponential? The logarithm. So this is going to be, answer to this is 7. Log base 12 of 12 to whatever the heck, I don't care what it is, okay? Log base 12 of 12 to something equals what you started with. It's that exponent, okay? Now, if you didn't know this, you could write the log base 12 of 12 to the 7th equal x. I'm trying to figure out what this is, okay? Where's my base? 12. In this log equation, where do I hide my exponent? So 12 to the x equals 12 to the 7th. What does x have to be for that to be true? Yeah, x has to be 7. Just another way of writing that, okay? But you really shouldn't have to go through this work. Log base 12 of 12 to the y is equal to y. Log base 12 of 12 to the q is equal to q. Log base 12 of 12 to whatever the heck is whatever the heck, okay? These are undoing of each other. Now, look at this one. Real easy. What's the answer to that? 12. Why is the answer 12? Because the logarithm and the exponential are what? Starts with an I. They're what? Inverse functions, okay? So this means if you take the log base 13 of something, and then you take 13 to that power, you've done inverse functions. It's like you've squared it and you've taken the square root, okay? So this is equal to 12, okay? Now this would not work if I can't write 12 to the log base 5 of 6. That does not equal 6. Why does that not equal 6? (12 to a power and the log base 5, are those inverses of each other? No, the bases have to be the same. But anytime I have 12 to a power and then I take log base 12, those are inverse functions, okay? So when you see something like this, 13 to the log base 13, you should just know, okay, exponent and log base 13, those are inverse functions. My answer is whatever that is right there, okay? Let's convert these, yes, yeah. Let's convert these to exponential form. What is my base here? What's the base? Lance. Do you need to dial a friend or what? You got it. What's the base? B. I like to call him Lance because he gets like sort of deer in headlights, you know, like you know it, but like it makes you nervous when I call on you. So you're all right. So in the log equation, which of those numbers is my exponent? Which of these numbers? That's my exponent. So to write it in exponential form, where do I write my exponent? Right, like that. So b squared is equal to what? What's the only other number I haven't written? 10. That's exponential form, okay? If I look at this one, what is the base? Pardon me? It's not m. The base is what? When you don't see a base, what is it? It's 10. This is the log base 10 of m equal 15. So the base is 10. Which of those numbers is my exponent? 15. What's the only other number I haven't written? M. Okay. So this is, when you look at a log equation, this is your base. That's your exponent. 10 to the 15 equal M. What's the base here? M. Which of those numbers is my exponent? Nope, 8. The exponent is always on the other side of the equal sign, all by itself. M to the 8th equal 20. Okay. What's the base in this one? What does ln mean? Ln means what? Log base e, natural log. So this means that the log base e of x equal -5. What's the base? E. Where's the exponent in this equation? Where's the exponent? -5. Exponent is always on the other side of the equal sign, all by itself. E to the -5 equal what? What's the only other thing I haven't written here? Come on, guys. X, okay? That's in exponential form, okay? This is not going over as well as I thought it would, but you have to spend some time here on this. Yeah, this is that day, okay? So now let's convert these to logarithm form, okay? What's the base? What's the base here? B. What's the exponent? 25. Why is the exponent not 5? This is what form? Exponential form. You know the exponent is 25. Don't get confused with logarithm and exponential form. So to write this in log form, this is log base what? Log base b. When I write in logarithm form, where am I going to put my exponent? Other side of the equal sign, I'm going to write a 25. What's the only other number I haven't written? 5. Log base b of 5 is equal to 25. This means that b to the 25 equal 5. That's the original equation. What's the base here? Log base 10. What's the exponent you see in that exponential equation? 4. So where will I write it? Yeah. And what's the only other number I haven't written? Is k. Log base 10 of k is equal to 4. What about this one? What's the base? 2. What's the exponent? -4. So where do I write -4? Yeah, over here. And then what's the only other thing left? That is a. What is the base here? Yeah, so this is log base 10. What's the exponent? -b. So I'm going to write -b. And then what else goes here is 1 over 100. Okay? So you just need to be very comfortable converting back and forth between exponent and log form. Now let's evaluate these logarithms without a calculator. The way to evaluate a logarithm without a calculator is to convert it to a form. What form would I convert it to? Starts with an E. Exponential form, okay? So I don't know what this is. I'm trying to figure it out. I'm going to write equal x, okay? Now, where's the base? In that equation, what's my base? 2, okay? In this equation, what's my exponent? X. So 2 to the x equal 32. What power of 2 is equal to 32? 2 to the what? 2 to the 5th, okay? Since 2 to the 5th equal 32, that means that x is equal to 5. So the log base 2 of 32 is equal to 5, okay? So log 2 of 32 is 5 because 2 to the 5th is 32. Okay. Let's look at this one. I don't know what this is. I'm going to call it x. What's the base? It's 10. It's not 10 because of this 10. Anytime you don't see a base, the base is what? 10. So what this means is the log base 10 of 10 is equal to x. That's what that means. When I don't see a base, the base is 10. Now let's convert this to exponential. What's the base? 10. What's the exponent? X. So 10 to the x. Oh crap. Yeah. Leave all your stuff, or yeah. Take it just in case.